Welcome back. In this video, we're going to talk about multiplying polynomials. And our goal here really is to systematically multiply every term, or maybe even every factor, in one polynomial by every term in the second or third polynomial. And then finally, we'll combine like terms and simplify. So even if we're working with like this first sample, where we've got one monomial multiplied by another monomial, while this is made up of several factors, what we want to do is gather the factors that we can multiply. So in sample number 1, we're really looking at, we want to multiply 8 times 9, and we also want to compare or combine our x factors, things with the same base. So x to the third and x to the first and y cubed. And then we can apply our laws of exponents to these other variables. So 8 times 9 is 72. X to the third times x to the first. Power times a power. We add our exponents. So we get x to the fourth and then y to the fourth. In sample problem number 2, what we want to do here, we're multiplying a monomial, negative 2x, times the trinomial, 9x squared plus 2x minus 5. And we have to make sure that we impose the negative 2x on every single term inside the parentheses. So times every term of that trinomial. So negative 2x times 9x squared, very similar to sample problem 1. Negative 2 times 9 is negative 18. And applying our laws of exponents, we get x cubed when we multiply by the first term. The second term, negative 2 times 2, negative 4, and x times x, so negative 4x squared. And then finally, negative 2x times 5, negative 2 times negative 5, we get a positive 10x. When multiplying binomials, you guys probably have seen the mnemonic device FOIL, which stands for first, outer, inner, last. And essentially that is a tool for reminding you to multiply every single term in one binomial times every single term in the second binomial. So FOIL tells us to multiply, so we'd multiply 2x times 3x, and we would get 6x squared. And then it tells us to multiply the outer terms, 2x times 2y plus 4xy. And then the inner terms, 5y times 3x, so minus 15xy. And then finally the last terms, 5y times 2y, and we get a negative 10y squared. And then we combine our like terms here. So we end up with 6x squared minus 11xy minus 10y squared. We can also multiply a binomial by a trinomial. Now we don't FOIL this, but we do have to systematically set this up. So what I'm going to do is I'm going to multiply the first term in the binomial times every single term in the trinomial. So I get 2x squared times 3x squared, we get 6x to the fourth. 2x squared times 2x, and we get a positive 4x cubed, and 2x squared times negative 1, and we get a negative 2x squared. And we can continue now when we multiply the negative 5 times every term. We can continue this process and continue horizontally, but I'm going to do this vertically because you can see how easy it is to line up the like terms. So negative 5 times 3x squared is negative 15x squared. And then negative 5 times 2x is negative 10x. And then negative 5 times negative 1 is positive 5. So, well, we didn't have that many like terms to line up after all in this problem, but you can get the idea here of how simple that is. So we end up with 6x to the 4th plus 4x cubed minus 17x squared minus 10x plus 5. You will also need to memorize some multiplication patterns. Some of those patterns, x plus y times x minus y is equal to x squared minus y squared. X plus y quantity squared is x squared plus 2xy plus y squared. Be careful here. X plus y squared is not equal to x squared plus y squared. Because it's addition and subtraction, that is a big no-no. You may not do that because we're adding inside the parentheses here. Okay? X plus y quantity squared or x minus y quantity squared, that really is x plus y times x plus y. And then when you FOIL that out, you get x squared plus xy again plus y squared, which is x squared plus 2xy plus y squared. So again, you may not impose that square on the x and the y because you're adding inside the parentheses there. Okay, so this is a big, big no-no. That you may not do. And then the other final pattern, x minus y quantity squared, again, is equal to x squared minus 2xy plus y squared. This is x minus y times x minus y. That's what x minus y quantity squared is, not x squared minus y squared. And when you FOIL that out, you are going to get x squared minus xy. You see here the inner terms, and then you get minus xy again. That's why we have minus 2xy. Minus 1xy, minus 1xy, minus 2xy. And then when I multiply y times y, you get a positive y squared. So memorize these multiplication patterns. They'll help you out. They'll speed things up for you. They're going to be very, very valuable. So let's take a look at these sample problems. 2x plus 5 quantity squared. I'm going to start with this one. Okay, we already know we may not just impose the square. Okay, this really is 2x plus 5 times 2x plus 5. And then you'd have to FOIL it. Now, if you know your pattern, you know that we can just square the 2x, so that becomes 4x squared. And then it's plus 2xy, so our first term times our second term, so it's plus 2 times 2x times 5. So that's plus 20x. And then plus 5 squared, or plus 25. So when we multiply all this out, it's 4x squared plus 20x plus 25. If you just put 4x squared and you just put 25, you leave out that linear term. We don't want to do that. Here's another example. We want to impose our exponents first. We do not distribute the 3. So this is 3, and then following our pattern, x squared, negative 2 times x times 2, minus 4x plus 4. So now I've used my pattern, and now I distribute the 3 and get 3x squared minus 12x plus 12. then you finally distribute. You do not distribute the 3 first, you distribute it last. So here's another example. You could distribute the 4y squared if you wanted to, but I see y plus 7 times y minus 7. That is our first pattern, x plus y times x minus y. So this becomes 4y squared times y squared minus 7 times 7, which is 49. Now I can go ahead and distribute the 4y squared and get 4y to the 4th minus 49 times 4. Well, 50 times 4 is 200, so that's going to be 196 y squared. So we've multiplied that. A couple of challenge problems. Remember that x plus y times x minus y is x squared minus y squared. And we have x minus y plus z times x minus y minus z. Well, show you a quick hint on this. Let a equal x minus y. So this really is a x minus y plus z times a x minus y minus z, which we remember our pattern, that's just a squared minus z squared. Well, what's a? A is x minus y squared minus z squared. Well, x minus y quantity squared, we have to go back to our other pattern. That's x squared plus 2xy. Well, it's not plus, it's minus. Minus 2xy plus y squared minus z squared. And we can do a similar thing with this other challenge problem. 2p plus q quantity cubed, well, that's 2p plus q times 2p plus q times 2p plus q. 3 factors of the binomial 2p plus q. Well, 2p plus q quantity squared is these 2 factors here. If we remember our pattern, okay, x squared plus 2xy plus y squared, well, 2p quantity squared, that's 4p squared, and 2p times q times 2 is plus 4pq, and plus q squared. So I've taken these 2 binomials and they have become that trinomial by using our pattern. I'll bring down my 2p plus q, and now I will need to go ahead and FOIL. I'll multiply the 2p times all 3 terms in my trinomial. So 2p times 4p squared, 8p cubed. 2p times 4pq is 8p squared q. And 2p times q squared, I get 2pq squared. And now I have to multiply the q times every single term. So I'll multiply q times 4p squared. I get 4p squared q. And I'm going to line that up under that one because those are like terms. The q times the 4pq, I get 4pq squared. And again, I'm going to line that up because those are like terms. And then finally, q times q squared is q cubed. So I've lined up my terms vertically, so my like terms are all matched up. My final answer, 8p cubed plus 12 p squared q plus 6p q squared plus q cubed. So we've shown examples of how to FOIL. We've reviewed our multiplication patterns. You'll have to memorize those. I encourage you to work on that right away. We've shown some examples where we've applied those multiplication patterns. And then we started with just multiplying a couple of monomials together and applying our laws of exponents. So that takes care of multiplying polynomials, and we will see you in class.